Part 2 of the video is on reflections. So let's take a look at what reflections are all about. Reflections are sometimes referred to as a flip. We're basically flipping an image over a line of some sorts. And so when we're reflecting any image over a horizontal or vertical line, we can basically count the distance that each point is from that line and then basically repeat that on the other side, sort of almost like symmetry. Whatever we do on one side, we do to the other. The line that we reflect over is called the line of reflection. And so let's take a look at some examples here. So it says reflect the image over the indicated line of reflection. This one says we're going to reflect over the y-axis. And so the y-axis is right here. And so we are going to reflect our image over that line. And so each point we can just count how far away am I to that line. So point C is 1, 2 points away. So then we count again, 1, 2 points, and that becomes C prime. B is 1, 2, 3, 4, 1, 2, 3, 4. That gives me B prime. D is 1, 2 points away, 1, 2 points away. And then A is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And that's A prime. And then we basically just connect our dots, making sure that we connect them in the same order so that we have A, B, C, and D. And it is important for all of these transformations that you label your points as, you know, A prime, B prime, C prime. So if you don't have the labels on there, you're going to miss some points on that. The next one says reflect over the line y equals 2. So what you need to remember back from algebra is if your equation is y equals a number, that is going to be a horizontal line. Whoops. And if you have x equals some number, that's going to be a vertical line. You may remember the saying hoi vux. That kind of may ring a bell. And so what are we reflecting over? We're reflecting over y equals 2. 1, 2. Whoops, horizontal line. What am I doing? 1, 2. I'm reflecting over this line, y equals 2. So all the y values equal 2 there. Same thing, we're just going to count how far away is each point to that line. So A is 1 point away, so then we put A prime here. B is 1 point away, so we put B prime here. D is 1, 2, 3, and we count again, 1, 2, 3. That's D prime. And then C is 1, 2, 3, 1, 2, 3. So C prime goes here. Again, just connect the dots. So it does look a bit messy because we kind of are all over the shape, but that's our reflection over y equals 2. What about if we don't have a horizontal line or we don't have a vertical line? What if instead we had to reflect something over the point y, or the line y equals x? So we're going to just reflect a segment here where j is -1, -2. So I'll plot that point, j. K is at 3, -4, 1, 2, 3, 1, 2, 3, 4. So we're going to reflect this. What are we reflecting it over? Y equals x. So how do I graph y equals x? Well, if you recall the line y equals x, if you pick any number for x, y has to be equal to that. So using my highlighter here, if x equals 1, what does y have to equal? 1. If x equals 2, y has to equal 2. If x equals 3, y has to equal 3, and so on. And so we sort of get this diagonal line that goes through all of these points here. And so I can draw that line. This is what we are going to reflect over. There's a lot of different strategies on how to actually reflect over these types of lines, but I'm going to give you what I feel is the easiest. Start with either up or down count. And then you're basically going to repeat as either a left or a right count. So in this case, since both lines are below the line, I'm going to count up to the line. And then when I get to the line, so from point J, I went up 1 point, and so now I'm going to go left 1 point. That way I've now reflected over that line, and that's where J prime would go. For K, same thing. I'm going to count up to the line, which is 1, 2, 3, 4, 5, 6, 7 points, and then I reflect left 1, 2, 3, 4, 5, 6, 7 points. And then that would become K prime. Kind of cool thing you can do with paper is you can actually fold your paper along this line and actually see where JK kind of flips over. It's tough to do that on the Promethean board here. All right, and let's take a look at this last one. We're going to graph the triangle. So let's graph these points here. So -3, -4, that's F. G is at -4, -1. That's G, and H is at 1, -3. And we are graphing this over the line y equals -x. So again, that means whatever x is, y is the negative version of that. So if x is 1, y is -1. If x is 2, y is -2, and so on. And so we end up getting a line that looks a little something like this. Whoops. All right, and so we are going to reflect our triangle, which looks like this, over that line. And so same thing, I would count up to these points, and now we're going to count to the right so that we can reflect over this line. So H is 1, 2 points up, and then go 2 points to the right. So that becomes H prime. F is 1, 2, 3, 4, 5, 6, 7 points up. 1, 2, 3, 4, 5, 6, 7 points to the right. G is 1, 2, 3, 4, 5 points up. 1, 2, 3, 4, 5 points to the right. That's G prime. And then we go ahead and connect. And there is our reflection. All right, that is all for reflections.